Okay, I think we can begin. Paul, do you want to move over to the next slide, please? Hello and welcome everyone to our webinar today, Weave GitOps Continuous Delivery for Any Kubernetes. Before we get started, I just want to cover a few housekeeping items. This call is being recorded and all participants are in listen-only mode. And if you'd like to ask a question, please use the Q&A panel at the bottom of your screen and we'll address those at the end of the presentation. So I'd like to introduce you to our speakers today. Our first speaker is Paul Fremantle, who is our VP of Product Engineering, and Paul Curtis, our Principal Solutions Architect. There's a short bio there, which you will be able to read when we send you the slides after the webinar, but let's move on. So let's begin, and I'll hand you over to Paul Fremantle.
Hi folks, welcome to the webinar. This should be fun. We're going to just briefly introduce Weaveworks, and then we're going to get straight into talking about Weave GitOps, which is our new product, and explaining how Weave GitOps Core and Enterprise fit together. And then I will do a little demo, Paul will do a little demo, we'll talk about some of the features and capabilities, and hopefully leave plenty of time for questions and interaction at the end. So Weaveworks is a awesome company. I joined nearly a year ago and have been working closely with Alexis, Cornelia and Steve and Paul and the rest of the team. We really coined the term GitOps and have been a huge proponent of this and really focused on driving the Flux tool inside the CNCF, which forms a core basis of all of our work. As well as many other open source projects like Scope and Cortex and EKS Cuttle, which many of you may use. We have some significant investors, both across the cloud space and the telco space, which is really interesting. That's a big convergence area. And many customers, including many large banks and other organizations that are using GitOps to drive their deployment and move to cloud native. And our mission is really to provide a developer-centric operating model for cloud native technologies. We really target platform operators and DevOps and developers who are trying to build a very consistent modular way of deploying and managing Kubernetes stacks, especially at scale. And we have some really amazing examples. If you were at KubeCon earlier this year, you will have heard Vuk Goynik from Deutsche Telekom doing a keynote where he talked about their platform Das Schiff, which is deploying thousands of Kubernetes clusters to the edge and using GitOps to do that. And that's really interesting because what we've seen is what we call the GitOps maturity model, and I talked about this at the GitOps days a couple of months ago, and actually I'm doing a webinar on this with Tiffany Wang, who's one of our CX team, in a couple of weeks' time. So please dial in for that. And what we've noticed is that there's this sort of maturity growth process that companies go through and organizations go through as they adopt GitOps. And what this typically is they start out without real GitOps, but maybe using Git to store and manage some of their operational YAMLs, but without full reconciliation and without really doing ongoing GitOps. So this is kind of day zero, but not day N. And then they soon discover that it's really important to manage the day N experience, to build a reconciliation loop so that you go into managing your applications in an ongoing way. And as organizations start to manage their applications, they realize that actually they can manage everything, the infrastructure, the cluster configuration, and the workload. And we see organizations start to manage multiple clusters and fleets. And then as they scale out, we see scenarios like Deutsche Telekom, where they're managing thousands of clusters in a highly consistent way. And this is really about managing many clusters without needing many SREs, right? We don't want to have to scale up the team every time we add a new Kubernetes cluster. So our product stack is very much based around this. So we've GitOps Core is really aimed at that application management and deployment scenario. And then we've GitOps Enterprise is aimed at level 2 and level 3 of the stack, basically managing clusters and fleets. So we're going to show you some little parts of that today. We don't have time to demo it all, but hopefully we'll talk about it all and show you some demos of the really key parts. So we've GitOps Core is built very closely on top of the Flux project I mentioned earlier, which is a Cloud Native Compute Foundation project, and very much a community-driven project, although ReveWorks do have some of the key maintainers of the project. And we have built with GitOps Core to be an open source, open core base for our overall product. And that's because, you know, firstly, this space is very much driven by open source, and secondly, we want people to be able to try, see how it works, and then discover the product, and then if they need further features, get it going. And there's just 2 commands required to get GitOps running on your system. GitOps install installs the GitOps runtime into a cluster, and then app add basically adds an application definition and configures that application to deploy into the cluster. And so it's really straightforward. There are a couple of different models which I'll kind of explain as we go through. There's a model of basically putting your GitOps configuration into the same repository as your application, or having a separate platform repository. And this is kind of important because this is our sort of model of, if you're just doing an application and you're a small team, you're in that level 1, you probably want the left-hand side. If you're in level 2 or level 3, you probably want to manage multiple applications against multiple clusters. That's really where the platform repository comes in. I see from a little red dot there is a question in the Q&A, but I think what we're going to do is show a little demo and we'll get to the questions later. So for this demo, it's really simple. I have set up a kind cluster. So it's a simple Kubernetes cluster running in Docker on my local machine, but this also works with other clusters. And so that kind cluster is there, but nothing's deployed. And the first thing I need to do, I have nothing else set up, so I need to actually install with GitOps, and I need to find my right window for that. I need to install with GitOps Core, and I'm going to go to the GitHub repo and just cut and paste this set of commands, which will basically download it from GitHub and install it. So this is reasonably quick. Just give it a couple of seconds more. And then I'm going to install this into my cluster. So there you can see it's the version Wego based on v0.16 of Flux. And I'm going to go Wego GitOps install. And that is going to basically deploy a set of controllers into my cluster. And you can see in this top window here, it's just creating, and it's going to wait for those to set up and start. And these are fundamentally controllers from Flux. So those of you who've seen Flux will recognize these controllers. While it's doing that, I'm going to just pop over and find a workload to deploy. So this is a simple example workload called podinfo deploy. It's based on Stefan Prodan's podinfo, and I am going to, if I can get all the Zoom bits out of the way, I'm going to take a fork of this repository, fork it into my GitHub environment. It's going to be pretty quick. And I'm just going to copy that SSH target. It has to be the SSH target for this to work. And in the meantime, we are cracking on. So you can see from my screen that most of the controllers have started up. Hey, perfect timing. So I'm going to clone that workload repository here. And I'm going to switch into that directory. And now I'm going to do that application add of this application. And what that's going to do is it's going to do quite a lot of clever stuff. It's going to go to generate a deploy key, which is using my, basically I have a GitHub token. So it's using that GitHub token to go create a deploy key. And there is one slight, we're still in an early stage here. It says committing and pushing Wego resources. That's actually not true. We've just updated it. So what it's actually done is it's gone and created a pull request. And you'll see this is very much the GitOps model, right? We create pull requests because that gives us the ability to track exactly what's happened. And so what that pull request is, if I just go and show you very quickly, is basically a set of file changes to add the GitOps, to add basically an app YAML and a GitOps runtime YAML, which basically define the GitOps runtime configuration to add this repository. So I'm going to merge that pull request, confirm merge, and I'm going to go back and I'm going to do a Wego app list, and it will show me that there is an app called podinfo deploy, and you can see that this is now actually deploying into my cluster. I don't want to spend too much time on this because there's some really cool stuff that Paul is going to show us. So if you're interested, there's a regular Weave user group that we've been running, and we'll take you through this, and I would actually show you changing that, changing this code here, seeing it automatically deploy into my cluster, reverting back to show you mean time to recover and so forth. But we're just going to assume you get that idea from today's demo. So I'm going to move on and hand over to Paul Curtis. I'm actually going to stop sharing at this point because he is going to share his screen so he can do a demo. Paul, thank you.
How you doing? So I'm going to answer the question that popped up about Argo and Flux. I'll put it in the Q&A as an answer, but those projects were going to merge. They couldn't do it without backwardly breaking a lot of things. And so they decided not to do that. And that was that was about a year ago, more than a year ago now. So that's where we are with Flux and Argo. Okay, so I'm going to talk about Weave GitOps Enterprise first. So let me get myself set. Okay, so Paul demonstrated Weave GitOps Core. So Weave GitOps Core is based on the open source tooling for Flux. So the principles of using GitOps and the methodology to deploy application stacks and make it simple and make it very easy to do. So Weave GitOps Enterprise takes that and goes to the next level by adding feature sets and ways to do GitOps at scale. Now, there's a number of features that are coming in. So we're going to talk about each one of those. Application user interface, so application management, fleet management, the concept of profiles and team workspaces. They have similarities, they have different use cases, but they both can be used. And we're going to talk about profiles a little more in depth as the way to manage and package applications. So I won't take a lot of time with this. We'll do a discussion, and then I'm going to show you the some of the fleet management tooling. So the application management UI, this is the ability to look at a deployment of an application, determine its state, make sure everything is running, determine what release or what version you're on, being able to see prior and forward versions if they exist. And this is a combination of not only being able to view what's in Git, because Git is the declarative source for all of this information, but being able to query the cluster and what is actually running at any given time, as well as the image repositories. So when you look at a deployment, you got to keep in mind that there's a deployment manifest or chart or something. There's the images, okay, the containers themselves, and the ability to move back and forth between container images and or manifest versions is what the application UI does for you. So this was demonstrated during GitOps days by our CTO, Cornelia. And fundamentally, this is the way that you would manage applications for any application. Now, this will tie into profiles. We'll talk about that a little bit later. But this is the mechanism that most customers are going to use to handle, basic deployment. The other thing here is that this is the kind of tool developers are going to want to use because it allows them to see what's actually happening with their application. Now, in GitOps, because everything's declared in Git, it means that they can see the manifest, but they may not see prior versions, they may not see dependencies, but they also can alter any of those things via the UI. So it gives them a view into the pods, services that are running as a part of their application and a part of their deployment. So this is a continuous thing. This operates all the time in a given cluster. Okay, profiles. This is going to take a little bit longer to explain. A profile is a way to manage a group of Kubernetes resources, Kubernetes objects, in a way that makes updating and upgrading and lifecycle management of that group of objects to operate together. So let me give you an example and I'll kind of show you how this would look. So if your application has a database, a middleware, and a front end, and developers are going to be working on each piece of that. Maybe not the database, but certainly the middleware and the front end. And they're going to be committing updates and changes. They're going to be building images and containers and pushing them to the registry and continuously doing this update. Now, if you use Flux, you can have your dev cluster just track everything that they update. So you can say, anytime there's something new, just deploy it and let's go and see what happens there. But when you get to production, this is not necessarily the way you want to do things. So what a profile allows you to do is to have the individual pieces, individual Kubernetes resources being updated. And yet the cluster, the production cluster, let's say, is not being updated until the profile is installed or upgraded. So a profile lists out all of those resources, but you deploy or install the profile in order to do the lifecycle management. So rather than saying Flux is pointing to all of the individual resources in a particular project or application stack, Flux is actually pointing to the results of the profile. So when I say the results of the profile, what am I saying there? So a profile is defined in a Git repository, and in there is manifests, charts, anything. anything the developer wants to put in there. Okay, it may be RBAC, it could be security things. Any Kubernetes resource can go into a profile. The second thing is that a profile can contain other profiles. Right? So we'll talk about how that works. But in essence, when you install the profile, what happens is that the profile gets expanded. So let's take this very simple case. The first profile, profile 1, contains some artifacts, and those are things like, charts and manifests. And in this particular example, it also contains a second profile. Now, all this is a way to manage and to propagate a set of artifacts. A profile, because it can contain other profiles, you may have one for the database, one for the middleware, and one for the front end. So you can build out very, very complex deployment strategies using profiles and nested profiles. Right? But when you actually go to deploy it, you can actually deploy it by deploying profile 1, and it will subsequently deploy everything that it sees, including the nested profiles. So what does that look like? So in this particular example, you have 3 profiles: provider, security, and app profile. When you actually go and say profile control, either install or upgrade or update, it actually will take all of the information in that profile, including nested profiles, and put it into the deployment Git repository that your cluster's Flux is watching. So what that means is that the profile is independent of what is actually running in the cluster, which is a good thing because it allows you to incrementally update profiles without actually having the update automatically go through to the cluster itself. It also means that you can have different teams maintaining different parts of the profile, right? So the provider and security profiles in this particular example might be the ops teams. And then the app profile may be the develop and DevOps teams, okay? But it isn't until you actually say, take this profile and install it, does it actually get deployed to the Git repository that Flux is watching. Now, a couple of quick notes. They don't have to be separate Git repositories because remember, Flux can use a path as well as a branch. So there's many different ways that you can set up profiles and the deployment repository that Flux monitors, either in one repo, more than one repo. They could be very different repos. They might be private versus public. There's a lot of ways that you can set this up. So let your imagination run away with you, but understand that a profile is contained in a Git repository path and branch, and Flux is monitoring a particular repository, branch, and directory. So you have a lot of flexibility. Now, what happens when you want to split these things up? Right, so we said you could do nested profiles. So in this particular example, Flux in the cluster might be monitoring more than one deployment repository. And due to security concerns, the provider and security profiles are maintained by one team, and they have right to those Git repositories. But the application is maintained by a different team, and therefore they would not want to have the same privileges as those who are maintaining the security profile, for example. So they do it in a separate repo, or depending on which Git software you're using, might be a separate branch or a separate directory. But in the cluster sees this source of declared state, right? And that declared state is always in Git. It's always visible. You can mix and match profiles with regular Helm charts and manifests. So you don't have, everything doesn't have to be in a profile, but it gives you a way to organize application stacks. There's another advantage to this. if you begin to think that you have 10 clusters, right, and you want to try out a profile, but only on one of them, right, you can actually target the profile and say, oh, it only goes to this cluster. So the application can have a target as well. And when you start to begin to think about how you deploy out to production, perhaps across regions or data centers or something like that, you want to be able to do this. Now, last point on this one, profiles are declarative. Like everything in our world, in Weave's world, everything is GitOps. So the profiles are declared, right? Which means that they get updated the same way that the manifests and the Helm charts and everything else gets updated. They are maintained in Git, so they are versioned. Okay, so all of the same GitOps principles apply to a profile that apply to any other Kubernetes objects that you're using in GitOps. Okay, so that's profiles. We're going to talk about fleets of clusters and what Weave GitOps Enterprise gives you here. Now, again, Weave is a GitOps company, so everything we do is GitOps, right? And that includes managing fleets of clusters. The method that we use to do this is the cluster API. So when you think about what defines a cluster, whether that be hardware, might be operating system, it could be a lot of things, and then obviously the Kubernetes itself and the version of Kubernetes. There's actually a lot of things that are going on there. To be able to manage those declaratively using the cluster API becomes very simple to handle because everything is, you can see it. Everything basically is observable in Git. The tooling that we're providing in Weave GitOps Enterprise allows you to do this both in an automated way, okay, and in a user interface, so an administrative interface way as well. So when you look at fleet management overall, it becomes just another GitOps step. So if you go back to the maturity model, right, now you can see that level 1 where Weave GitOps core lives, and now level 2 and 3 are where things like profiles and team workspace management come in, where you have to manage applications across fleets of clusters. And then if you go the other way, closer to day 0, you now see that the cluster API and GitOps manage that piece. Now, everything here is GitOps enabled. Weaveworks provides the tooling to allow you to do that. We draw very heavily on the open source to do so, but we also bring in our best practices, our knowledge, and we are very, very involved, for example, in the cluster API community. When we find things that would be better to work in this environment, we tend to upstream all of it. So you can now say, I can manage clusters this way. Now imagine booting a cluster. How does that look? So all of the cluster management is done via, as I said, you can do this declaratively with manifests, and I'll show that during the demo in a couple minutes, or you can use a user interface to do that, or you can use both. It doesn't matter. The machinery that handles this is the cluster API management tools, okay, so those controllers. The places, the targets of where you can build things is limited only by the cluster API itself. So currently there's 10, 12 providers there. As we work through this, Weaveworks will be certifying them, i.e. testing them against the cluster API tooling to ensure that they work. And the other thing that's come out of the whole cluster API as it's been developed, and now it's up to version alpha 4, is that the need to be able to define default clusters, need to be able to template things that are very specific to certain clusters. So that's part of what we'll demonstrate in the user interface. So when you begin to see how this flow works, you say, okay, we're going to create a cluster. We're going to choose a template from the provider, and CAPI providers are AWS, EC2 and EKS, Microsoft Azure and AKS, GKE, vSphere, Equinix Metal, DigitalOcean. So there's a lot of them. And each one of those obviously has some basic information like how many control nodes and how many worker nodes, but it also has some information that's specific to that provider, like credentials is probably the most common. But also things in AWS, for example, what region? Okay, where do you want it to run? Those are in the templates. So you pick a template, okay? Then you choose a repo and you say, okay, when I bootstrap this cluster, I want it to bootstrap the application stack or the cluster components or the baseline cluster configuration from this repository. And you click create. So what does that do for you? What you end up with is a very similar process to what Paul described with Wego apps. You basically get a pull request with all the templates in it, everything all set to go. Once you commit it, the Weave GitOps Enterprise with a multi-cluster control plane picks that up because it has Flux installed and applies those to the cluster API, and those clusters are created and provisioned. So right now, this is in test. You're going to see some beta. So please, give me a little bit of leeway on what you're going to see, because hopefully everything is going to be working as expected. So 1 second while I bring up what I need to see here. Okay, so I've got to move this out of the way so I can get to this. So what does a cluster create look like? So let's start there. So the first thing we talked about was templates. So template is fundamentally how a provisioning in whatever service is described. Now the templates are something you can control. So I'm going to just bring one up really quick, and Paul Fremantle or someone make sure that they can read what I'm showing. Just want to make it big enough to give general idea.
I have bad eyesight and I can read it. So
okay. So when you look at a template basically says, what information do I have to ask the user for? Okay, that's this part. And this is the prompts, right? Now, obviously, you can control what's in here. Now, you'll notice this happens to be for EKS, and you notice there's only 2 machine types. There's a lot more than that, obviously. And the second part of this is the actual CAPI template itself. This is provided by the CAPI provider. So when they publish their CAPI provider application, this template is included. And so what you can see here is we're prompting for cluster name up here, and in the CAPI template, it gets replaced down here. Okay, and you can go through all of this. This is a rather short one, but you can make the CAPI template very simple because you really only need to define 2 things, which is the cluster and the machines. It can be very, very complex depending on what the provider has. So EKS, things like security groups and VPCs and subnets and all of those things come into play. They can be placed in this template. They can be prompted for by the user up here, or they can be hard-coded. So you can actually just say, oh, they always have to use this CIDR block. They always have to use this CNI. They always have to use this key, this IAM user, things like that. This is all up to you, right? And again, this isn't a standard Git repo. So when I go back to the interface and I say create a cluster, what I see, and this is a little hard to see because it's gray, you see all the prompts. So if my cluster name is, okay, we've GitOps Enterprise 2, it fills in everything, right? So remember I said we had some limited regions, so I can do that. The key name is something I have to put in, right? Control plane machine count in EKS, Kubernetes version, right? These are all the things that are specified in that template, okay? Here's my machine types, right? And I'm gonna make it 3 nodes. And I'm gonna make the machine type for the workers this, okay? Now I go down here and I say, show me. What it has done is it has created the actual CAPI template that is needed for you to build this cluster using the cluster API. And here are the definitions, right? And for example, just to give you a general idea, the cluster API only really requires 2 things. It requires a cluster, a kind of cluster, and it requires a kind of one of the machines. And in this particular machine example, it's right here. So following GitOps principles, we're going to create a branch for this. And we're going to say new cluster. You can put notes in here, anything you want, and we'll just hit create the pull request. Done. Now, when I go back over to the repo, there's my pull request. Now, you can actually see, if you want to, go in and look at what got created. But here is the spec. When I commit this, in the same way that Wego core did this for an application, when I do this commit, I merge it, it will actually build out this cluster. So I'm going to stop and go back over here just for a second and talk about Weave GitOps Enterprise in general. So templates and clusters is a very straightforward thing. Weave GitOps Enterprise actually has a number of additional management features, which I'm actually going to show you in the current version so that you can have a good idea of what it looks like. So in all of what we do, we always have GitOps. So we talked about profiles. There's also another idea of team workspaces. Workspaces are a similar concept, except that rather than being a Git repo, it's actually declared as a manifest, and you can put restrictions on it. So this is very specifically Kubernetes namespace based. It uses namespace RBAC, roles, and network policy to build isolated tenants. But each workspace, like everything else in Weaveworks, is attached to a Git repo. And here's the manifests that are going to get deployed into that workspace. So in Weave GitOps Enterprise, we combine all of these tools together. And we give you a couple of very straightforward design patterns about bootstrapping the day 0 plus half a day cluster components. So the things that you always put into every cluster, right? So tools vis-a-vis observability, security, service meshes, ingress, all those sorts of things, right? But we also give you the ability to do tenancy and declare tenancy in this way. In all cases, the multi-cluster fleet management allows you to observe the clusters. And you'll notice we're pretty much agnostic to where they run. So EKS, AKS, on-premise, data center, virtual machines. I run it on kind clusters on my laptop in Docker. We're very agnostic to that, and the product does work across all of those platforms. So I'm going to jump back over to our slide presentation, which I hope everybody can see. Yeah. And we'll go with questions. Okay, so now I have 2 questions. Oh, okay. So Minyaz, you asked about the substitutions in the CAPI template. The ones that are substituted with the dollar braces, okay, are the ones that are coming from the UI. Those are the substitutions we're doing before we actually create. The other ones are CAPI level. So those would be things that potentially the provider would fill in when it's actually built. So there's 2 different ways to do this. For the most part, you won't use the double curly braces. You will probably use the dollar curly braces to do that. Okay. So let me see. I've got another question. Do profiles solve the scaling issue of having 40 microservices repos? Yes, they do. And team workspaces do this as well. So rather than having a repo per cluster, for example, or 40 microservices, you can choose to have the profiles all in one directory in the repo. Okay, or if you have, let's say, 3 or 4 different application stacks in a repo in directories, you can have profiles be just another directory there. And when you actually configure Flux, you point it to the profiles directory rather than the individual ones for each of the projects. The other thing is that when you talk about the PRs, right? So if you're doing PRs on the microservices, the individual parts of the application, those can be kept completely distinct from the PRs for the profiles. And that's the whole purpose, right? So the developers can be continuously working their projects and their commits are put in that will not affect the cluster, will not get deployed to the cluster until somebody takes an imperative action. And to answer your question about P control, profile control, yes, it can be automated. It's standard binary off the shelf. It only needs credentials to the Git clusters, Git repos. It does not need credentials to the Kubernetes API. Because all it's doing is taking your profiles, expanding them out, and then placing them into that deployment repository where Flux picks it up. Right now, backward compatibility, rolling back, you have to think about the profile is going to take whatever you've pointed it to. Now, it could be a directory, a file, or it could be another profile. It could also be a repo. So the git commit ID of the application will come into play as far as what profile does. But remember, what it's doing is it's getting current head and expanding everything out. If you need to roll it back, let's say one of the 40 applications needs to go backwards, you roll it back in the repo, okay, and you re-upgrade the profile. It won't mess with the 39, but it will change the 40th. I hope that got that. That was a lot of explanation in very little time. Okay, this is a conceptual thing that Tracy asked. When I talk about an application, you can view an application any way you want. We have customers who view an application as a single microservice. We have customers who view an application as a group of microservices. We have customers who view an application as the complete stack, including database middleware and microservices. And then we have other customers who use the application concept to segregate their teams rather than code. So the blue team, the red team, and the yellow team, okay, they have their own profiles. Now they may be working on multiple different parts of different applications. How you organize this is totally up to you. It makes no difference to the application software how that works. So that becomes a really easy way to say GitOps will fit pretty much everywhere, right? Because you can use GitOps. As I said, we have customers who use GitOps and they define the application stack as a stage: dev, QA, integration, stage, production. I mean, that's one way that they do it. In fact, one of the big bank customers we have, when they deploy a cluster for development purposes, they actually build workspaces for each of the stages rather than for team, application, or microservice. There's many different ways to organize it. I will make one comment: the major difference between a profile and a team workspace. A team workspace utilizes Kubernetes namespaces to provide isolation, so it becomes a tenant. But a team workspace can be put in a profile, and profile can be put in a team workspace. So you can do it either way. Profiles are much more flexible, okay, because they basically can touch almost anything in the Kubernetes cluster that they're allowed to. Okay, so whatever Flux is allowed to do, a profile can do as well. So they have greater power, which also means that you got to be a little more responsible. But also keep in mind that you can use profiles for things like Bootstrap. So day one, if you will, the initial application stacks that are installed in the clusters. So you could create profiles for security, create profiles that have to be installed at bootstrap time for the cluster, right? And then the applications could be added later. So keep in mind that you can have more than one profile installed in a given cluster, and you can choose to install a profile or not. But the scenario that we're kind of seeing with our customers and the ideas that they want to do is that they want to bring up a brand new cluster and they want to install a single profile. And that single profile may install applications or other profiles, but typically what they're looking for is to build a baseline cluster that is definable and always the same. So it's not going to matter. Any other questions? Okay. Paul, do you have anything else you want to add here?
Yes. So if you're interested in with GitOps Core, then there's a free workshop this Thursday, and the sign-up link is there. And one of my colleagues will be going through those getting started steps in more detail. And if you want to try out that early release of the multi-cluster fleet management, then please contact me or Paul, and we can point you at the docs for it. As Paul said, it's still a beta release, but it is available if you want to try it.
And so in 2 days' time, which is Thursday, we have a GitOps workshop, and the link is there for that as well. So you can just check in and go ahead and do that. We have a bunch of different things that we're working on as well in the Flux community. So keep your eyes peeled for Flux-based and Weave GitOps core applications and workshops that we're building out. So we can be contacted, all right? But Weaveworks in general, if you have sales questions or you're interested in a demo, you can always contact sales at Weaveworks. Or contact myself or Paul, the other Paul, if you have any other questions. And I do see that I see one question came up? Hang on. So that's a good question. I don't see why not. The question was, is there a way to use Terraform to install GitOps instead of Wego? Yes. But you would be back to using the standard Flux tooling to do that. And what you're going to get is a single cluster without any application support. You're just going to get plain Jane Flux. So as of right now, to get the application installation and the pieces to go with that, no, there isn't a way to do it yet. So are there any other questions? Otherwise, we'll say thank you very much for coming. And I hope this was informative. Please get in touch with us if you have any questions. And is there anything else that we need to add, Says?
No, we will send the video recording and the slides over to you either later today or tomorrow, so you can catch up and have access to all those links as well. Thank you both. That was very informative. I learned a thing or two as well. And until next time, goodbye.
Thank you very much. Thanks, Paul.
Thank you. And